Hello everyone and a warm welcome to Mydbops My Webinar Edition 44. I'm Shiny and I'll be your host for today's session. Thank you all for taking the time to join us. We are glad to have you here for this very informative and eye-opening session. Today's topic is 10 MongoDB anti-patterns that cost you millions and how to fix them. Our speaker will explore common MongoDB mistakes that many teams make without even realizing it, mistakes that can slow down performance and increase cost. Our speaker today is Manosh Malai, the CTO of Mydbops. Manosh is also the MongoDB user group leader in Bangalore. He's a tech blogger and a regular speaker at database community events. He leads the MongoDB team at Mydbops. He has helped many startups and companies make their MongoDB systems faster and more efficient. Today, he is going to share some real examples of MongoDB issues he has seen and how to fix them in simple, practical ways. Today's webinar purely depends on your engagement, so feel free to drop your queries in the comment section. We will address them immediately. So, without further delay, let's welcome Manoj to begin the session. Over to you, Manoj.
Thanks, Shiny, for your wonderful introduction. Hi, everyone. Welcome to MyDB My Webinar 44th edition. Today, we are going to discuss about 10 MongoDB anti-patterns that cost you a million and how to fix them. Myself, Manosh Malai, CTO at MyDB. I specialized in high-performance MongoDB consulting and have worked with clients across critical production environments from startup to global enterprise. Today, I'm excited to share some real-world anti-pattern and architectural lessons that have saved our clients from million in cost, downtime, and performance. Whether you are managing MongoDB and Atlas, EC2, or hybrid environment, these insights are designed to be directly actionable. About MyDBOps. MyDBOps is a database management and consulting provider founded in 2016 and assists 800 plus happy customer, AWS service partner also we, and we are also PC and ISO certified organization. Coming to the agenda, this anti-pattern basically we are covering from schema, querying and index, and operational. I also like to interested to share few important like infrastructure pitfalls and monitoring blind spots too. Coming to the anti-pattern in schema design, before MongoDB biggest strength is its schemaless. You don't have to predefine your field like relational database. That is the one of the greatest advantage everyone ever. But that itself, the mistake all developers are doing every day in their initial development phase. Why? Because the flexibility any NoSQL database giving is not meant to skip the design. Whenever you are designing your schema, you need to understand your application read write behavior and what kind of query shape you are going to create and what kind of syntax is going to work. And these all need to be considered whenever you are going to design the scheme. So I'm going to share few important pointers people always do in their day-to-day development or schema design in the initial phase. I'm damn sure it will help every one of you ways. Unbound array. Unbound array is a common mistake we see in development without growing the limit in the embedded document or in even in the array directly itself. It looked conventional early, but it turned into a performance time bomb. Why I'm so much exaggerating this particular thing is MongoDB giving this flexibility and have a also encouraging developer to use array or embedded document, but there's some consideration always need to be in place. Otherwise, the document size may grow uncontrollably and other housekeeping work comes into the picture. Particularly when we are serving with lot of clients, once the document grow and they are doing slicing and they are pushing and this housekeeping work itself major part of the application behavior because we serving few clients particularly having this issue for a very long time. The only recommendation we gave is move those array subdocument or embedded document into the separate collection, make it as a reference in the main document. It may be one-to-many model. While you are having this unbound array kind of things in your schema, sure you will face memory issue, IOPS issue, and poor query performance too. Basically, the people who is having unbound array and they have the performance issue, there are two kind of problem will come into the picture. One, when they are reading and when they are doing comparison between two array multi-key, there the index efficiency will totally fail. And when the document grow unconditionally in some size, then maybe inside the application or outside, you need to do purging of that particular growing document also. This kind of problem will come into the picture when you are not having very proper uh, solution for your requirement. I like to share few examples. I like to showcase here. If you see, I have a schema with visible role in customer tag, and this is one multi-key problem what we are seeing. In the problem, in the query, actually problematic query, you see, we are using OR operator and putting something inside the array and visible role in and customer in. This this query or this schema won't scale because the multi-key index won't perform as expected way. It nearly go to the collections. This is this is this is the one part of unbound array what I'm talking. Unbound array is not just about growing. Whenever you are developing a schema, you have a array like visible role and customer tag. You put lot of information. That is one kind of unbound array problem. And another kind is you have two array, and in majority of in your query operation, you have this kind of or operations or or some different operation which need to be performed or in operation need to be performed. The index won't be that much effective. This is one example. Other thing, regular expression and lookup, what we showcased here. Coming to the document bloat. Document bloat is differ from unbound array. Document fountains, you are adding more field information in one document. I like to share one example here. I'm having a book. I'm running an e-commerce website. I'm having a book document. I'm storing all comment and review of the book inside the book document itself. So if you see, it start with one or two or five, it's good enough. But if you are storing all 500 or 1000 comment about the book in the one document, it will be big size. So basically, MongoDB have a upper limit of 15 MB. But basically, what I recommend is the max 1 MB if you're crossing the red flag. Why? Because whenever you are querying the document, it's coming to the disk cache. From the disk cache, it is coming to the RAM. From the RAM, you need to do all your business operations. It totally affect your entire performance. And it also lead to a lot of IO risks. Because according to the MongoDB, one page size is 4 KB. If I have a document itself 1 MB, it is so meaningless. I need to fetch all the pages and I need to do a lot of eviction problem will come into the picture. So it is too noisy environment, I like to say. Again, how to handle this kind of scenario? So normalize the large component. Move your commands or move your information into the separate collection. Again, do whenever you fetch those documents using lookup from the application level or occasional lookup from the database level. This is the recommended way we receive. Coming to the massive number of collection. This is one interesting problem. Recently, we are observing in a lot of multi-tenant application. There are two different approach people are doing nowadays. One thing, um, they keep all the multi-tenant clients in one database. This is one variety of thing. So For one client itself, they will have 250 plus collection. If I have a 10 clients, it's huge. It's grow, it's growing wire tiger meta overhead also. What is the problem, Manoj? What so MongoDB won't scale with large number of any database is not recommended to store more number of collection. In MySQL be called tables or collection. Why? Because it increases the memory usage in the MongoDB perspective. It load all underscore ID index for every collection. It's lower the startup time and poor performance cluster wide, inefficient of data locality model. Everything is coming to the picture. But uh, based on my experience, it won't affect the performance as much as we are speaking, but it affects the daily maintenance and startup. If something crash and it's coming back, that time it will be totally screwed us. So this is one of the key points. So in this model, what we always recommend, if you have a basically we I call it as a flat schema model for in the MongoDB perspective because we are not designing for RDMAs. When we are designing for MongoDB kind of schema model, I always recommend to keep as much as information in one document, considering all the unbound array or bloated document model. Consider as much as information. Don't try to normalize, denormalize, and keep the information in one document. But also key factor, what we learned previously, bloat and unbound array need to be come into the picture. But I attend a lot of client. I cannot name it, but today also I had opportunity to discuss with one of our client have similar issue. But my experience, it is mostly multi-tenant application. Times it is here and there I can see floating collection people are creating, but that can be controlled at certain environment because they create and that they delete it at certain duration. If it is a long time, then it is a chaos. Operational overload. This is one of the pain point for all the DBA because application team and the DBA team is not having enough coordination. Developer will change their schema and they release something different and they introduce new query shape. They introduce new query and something went to production without knowing to the DBA. It start creating noise once the development is released. Then there will be the firefighting situation comes. Then DBA comes and they found some new queries and that query is not using right index. Then these all things come. So I always recommend whenever some new schema is developed or new schema changes happen in your application and you are introducing new query shape, I always recommend to speak with your DBA team and get their recommendation on the query performance, whatever you are going to release, and get their opinion. Do we have a right index in the place? I recommend these all best practices need to be followed, and once they approved it, you can roll out, and they also be ready for this. What is the advantage? Because since MyDBOps is a database company, it is not one client. We are serving for 100 plus client. When we are serving for 100 plus client, I'm talking about Mongo. If any five clients creating noise at one day, the entire day is occupied with the five clients. So we always work with our client development team, stay touch, and this is the way we improved. We are reducing our firefighting situations, and this all created by relationship. But this one important step we need to follow. And why bad schema equal to poor performance and higher cloud price? This is what we are talking. When you don't have a good schema, you are spending more energy in spinning bigger instances, high CPU, high memory, high IOPS, based on your read-write behavior. This all come. It automatically increase your bill. This is what very important. The next, before going to the next part, I also like to share a few anti-pattern. We already discussed few things, but let's keep it a review here. So one thing, don't keep everything in one document and don't overuse reference also. This is too contradictory, but you need to be in the middle. So don't try to keep everything. If some information you don't fetch all the time, and it is a very big or it grow free, always don't keep it in one document. More as a reference. but don't use the reference. It is a flat model. So understand this problem statement and choose wisely. Ignoring indexing design. So whenever you are designing a schema, you need to think about your query pattern. Whenever you are thinking about the query pattern, you need to understand what is the high cardinality field I'm having, what is the frequency of the query. This all need to be understandable, and you need to create that solution, create that use case, and work on that use case. And the fourth point is growing array without bound. That already I told. So in this situation, what we always tell is move to the separate collection for reference. Too many connection. So best example is people will create collection based on the floating points and everything, and misusing of TTL index. TTL index, one of the interesting problem. I always talk. Uh, why? Because people created a TTL index, but they don't have a correct parameter monitoring at their end. In background, every minute it come and delete certain amount of document, and it affect the IO. That IO latency implicate the query latency. I believe I have another slide very detailed about it. We'll talk about it. So other bonus anti-pattern is people override the underscore ID, object ID, and they use their string. It is not good practice since everyone know underscore ID is a unique, and it create index by default. If something goes wrong, or you are creating big string over there, that index size also grow. This lot of challenges will come into the picture. And putting document inside the binary information into the MongoDB document is also not recommended. And storing counter in document is how you handle what I'm talking. Instead of you have some counter like 1, 2, 3. Instead of updating that, you can use incremental operator to increase the counter. And another very important point I like to share: relying on dollar group for core use cases. I have a client. Sorry, we have a client. They have some dashboard. Whenever client coming logging in, they land in the dashboard. This is one scenario. And whenever they are doing some business operation and they are submitting something, and again they are coming to the dashboard. So in the dashboard, this majority of queries are using group. Group, you guys know, aggregate. In aggregate, group is a block stage. So whenever they are doing 30 to 40% of application query on the dashboard page is doing a group and doing some replay, giving some replay. So in all the time, this group will create some noise in the system. So if we are using dollar group in majority of query, that page that page having lot of group query, and that query is creating lot of noise. So we I always recommend pre-aggregate the data. Do something and pre-aggregate the data in the document or some collection or materialized view something, achieve the result from that instead of doing every time relying on dollar group. Anti-pattern in query and index rejects on large collection. One very important thing, uh, so MongoDB is not for text. MongoDB is not a text search database, but MongoDB give freedom or flexibility or advantage to use the regular expression in their collection. But don't build your entire or major feature on regular expression. That is one important point I like to share. Second thing, whenever you are using regular expression, make sure you are using anchored prefix. Otherwise, uh, it won't use the index effectively, even regular expression index effectively. It affect IOPS, memory pressure, and other things. It affect other query performance latency also. This is one particularly in larger collection like auto completion. These are the very important places we use regular expression. I understand you build an entire solution on MongoDB, but if that particular feature is contributing the overall journey of the user in application is very minimal, then it is fine. If it is a major feature, your your important journey is itself there, then it is not the recommendable. I always recommend enable change stream, capture the data and put it into open search kind of solution and do that. That is always recommended. Multi-key index on larger array. As we talk, when unbound array, the same scenario here. So even I showcased on tabular column what is the impact and what is the solution we can do. This is the same things will be applicable here also. Override entire document intentionally. So this I'm not sure how many people from MongoDB DBA world itself uh, come across this one. The thing is, because this uh, findings we always do with all consulting clients audit during audit assessment part. Why? Because what majority of developer doing is if they need to update something in their existing document, they retrieve the document from the database and they change the entire information, whatever the way need to change or whatever the information need to change, and delete and reinsert this one with the same underscore ID. I hope you guys are able to visualize what I'm trying to say. So it's how we capture this kind of problem statement. We always do analyze the op log to understand how the application is updating the existing information in the database. What is the impact? So basically, uplog will grow. Why? Because I'm updating the entire document again. If, for example, you have one document, in 1 minute I'm doing 5 update operation over the document. You can visualize yourself how many update operation, how many same document will be replicated there in that place. So, what is the problem? There is a knowledge gap, or people may fail to realize to use correct operator. So, always use set operator, incremental operator, dollar push operator, or the unset operator based on the use case or the requirement, and update the document. Don't override the entire document always for the requirement of setting some information inside the existing document. This is very, very important in the update behavior. Uh, in my overall experience, at least 30 to 30% of my existing clients did this. Then we recommend them to use this operator. The overall uplog health became good, and the overall IOS operation got ready of this. All came from our experience. Operational anti-pattern. Ignoring the wire tiger catch behavior. I hope everyone will come across worksite health, eviction, those important parameters. But but there is some important thing people need to consider, like if your application is heavily write intensive application, you need to configure your white tiger eviction policy properly. If you are seeing more eviction in read from or write, and based on the application behavior, you need to tune, or you can increase your white tiger cache size or upscale, and or you need to find your slow queries from the log file or enable profiling to capture those information. So there are 3 to 4 parameters you need to consider. I will repeat it again. If you have a vertical cache, that vertical cache, you are receiving more eviction. So while you are seeing more eviction, the second thing is, sorry guys, the second thing is you need to uh, you need to see how much I'm reading from the disk, or how much dirty I'm flushing back to the disk. So these 2 parameters you need to look into. If you're reading more from the disk cache or RAM, if you're reading more from the disk cache or disk, that means your cache is not much enough for your system. Yeah. So that impact your read operation. That will affect your read operation. Read latency will be high. If you are doing more write, if you are doing more write, your IO weight is higher, like you can see top command and those places. If you are seeing more IO weight and Mongo start also, you can see dirty. If you are going more than 5% dirty, that means your system getting more IO pressure. Then you need to upscale your IOPS, maybe bandwidth part or IOPS part. You need to understand if you are if you are affected by bandwidth part, you can do certain tuning at the eviction policy and you can increase it. You can refer some blog from MyDBOps website also how to tune the MongoDB eviction. You can tune that and you can increase that aggressive of writing instead of waiting to accumulate more data and flushing in one time. You can increase the eviction policy to frequently flush the data, and that place the bandwidth problem will be reduced and you can improve the write performance. These all parameters or this consideration you need to keep of while tiger catchy behavior. Over optimizing while tiger compression. This is one of my recent experience. We have one client. We While we are doing upgrade, we moved them from Snappy to ZSTD. Unfortunately, we didn't do enough benchmark and those things because we are in the assumption based on our learning from logs and recommendation from the things, MongoDB things. Um, what we learn is okay. Snappy ZSTD is a combination of zleap and Snappy, so we moved it. But what we observed is in Snappy, the query performed 100 ms. When we move to ZSTD, it goes to 400 to 500 ms. I'm telling average number. Even sometime it went to seconds also, based on the query cardinality that particular field and everything. We did a lot of homework and we tuned all the parameter. We upscaled the machine to 4x also, but we didn't see the performance. We increased the IOPS. We moved to GP3. I mean GP3 IOPS, provisional IOPS like 16K IOPS. Then we moved to IN2 and IN3. There also we didn't see any performance. Then finally when we perform the perf top in the Linux, that time I observed it is taking more amount of the time in compress and decompress the data. Then we realize, okay, this is the problem statement, this is the chain, that STD is the culprit. Then we created one replica with Snappy and make it as a primary or secondary and push the read. Then we came to know this. So over optimizing white table compression also one important parameter here. So what we did then, whichever collection we do less read, uh, uh, we enables that STD for that particular collection. Whichever collection we are doing more reads, we made to Snappy because we believe latency is a very important thing, and uh, we balance in way we balance for other collection to enable ZSTD. Brian, the final part is blindly relying on MongoDB Atlas. So MyDBOps is not just supporting clients in community environment or on-premise. Even we have a major bucket in Atlas clients also. In all our first call with Atlas client, they will ask this question to me or my team. Already Atlas is giving a lot of things. Why we need you guys? We always say, okay, yes, Atlas is a wonderful solution, but uh, but it giving the solution to review to enable to automate few things like backup, recommendations like performance advisor. This thing is there, but there is a lot of requirement. Some database engineer need to be there to look some other parameter, understanding your application behavior, understanding your read pattern and write pattern, make sure you are properly upscaled or properly auto scale feature is configured. This all someone need to be there from your end. So that place, what we recommend, we have few clients before coming to us. They frequently auto scale from M40 to M60, and whenever it come down in back. So That time performance advisor itself give a lot of recommendation, but they don't have appropriate team to handle that recommendation, or they don't know whether that recommendation will help them. So in that place, as my DevOps engineering team will come into the picture, and we will analyze and we'll tell, okay, these recommendations are good, it will benefit a lot, and we will help them to improvise in better way, and we control the auto scaling and keep them in M40. It benefit them to save good amount of money, and we also help them to monitor their unused index, duplicate index. We recommend that way. In certain clients, right, we have very controlled parameter change in Atlas, but we can reach Atlas team to uh, tune some parameter in backend also. Even that we did, and we help our client to scale them, and they control with control cost also. This all we can do through Atlas. So what I'm saying is, don't blindly rely on Atlas default setting. Either you can reach Atlas PS team or you can reach MyDBOps. We can help you guys to control your cost on your spending and those things, and with the performance and scaling perspective also. I have bonus recommendation also, but in my talk I highlighted 10 plus. I like to take opportunity to discuss few more things also. Deployment and infrastructure pitfall. So in AWS or any cloud provider, there is a availability zone. You can put your node in different AZ. But the problem is when you are placing your node in different AZ, and application is reading the data from that particular different AZ node, you will have a query latency. So you need to design your architecture in certain way, read the data from the nearest node. Whenever something goes wrong, you need to go there. This kind of setting you need to be considered in your driver setting, and you need to do. Otherwise, you will have application latency and other parameters also going to. If it is a physical infra, even it is worse, because people in physical infra they create a DR and they fall into the split brain problem also. We had a lot of client in the physical infra with the split brain model. Then when they came to us, we solved it, understanding their requirement and changing the priority and voting priority and hidden node and those parameter change, and we control the issues, and they are stable. And in the cloud, people know that there is a bustable instance. For cost saving, people move their critical environment in the bustable. The problem, it is a good certain stage, but even your CPU and everything is good, your performance of your database is worse. That time, maybe your CPU credit may be expired or something like that. So, since we are in the cloud world, where you are putting your system, what is that, and uh, what are all the metric we are monitoring, not the regular metric. So that's what I'm trying to say. Putting your critical component, critical workload instance in the bustable instance is not a, but make sure you are make sure you're having appropriate monitoring solution to see all this metric. But what I always recommend, keep your critical workload in instance like MRC families. So that is the best practices. And another important parameter is not using Emperor and persistent volume strategy. Very short, I like to say MongoDB have three important things in the data file based. One is log, another one is journal, another one is data files. Whenever we are designing this, we always push the log to separate volume and journal to separate volume and data to separate volume. Log, I can keep low cost disk, and data I will use GP3 based on the system workload and anything, maybe N3 also, N3. And for journal, I use Imperial. So why? Because you guys know every 60 second, 100 ms, I will do some housekeeping things in the background Mongo, then flushing the data. Then this thing would take all my IOPS of the data disk. So we will keep this all separate with better cost. What people now doing in the high critical workload instance, they increase the provision IOPS. Whenever journal is doing its housekeeping work, the maximum IOPS will be sucked by the journal itself. So this kind of partitioning model will help you to balance the cost as well as the performance. Monitoring blind spot. So no observability layer on Informametric and Mongo is very serious to be considered. So when we are handling MongoDB, not just monitoring CPU, memory, IOPS, you also need to monitor like white tiger cache, eviction, log, write conflict, and these all important MongoDB metric need to be monitored. You can use Prometheus Grafana based solution, which is available in the open source community itself. You can use Mongo exporter, Node exporter, Proc exporter to capture that information and send to the Prometheus data source and build some wonderful dashboard to monitor it. And there are also some alert manager solution which is exist. You can use those things to build your observability platform. And I also like to take an opportunity to explain about MyDB's MongoDB monitoring solution. MyDB's MongoDB monitoring solution is a robust solution. It have intelligent alert system, query execution time deviation, unexpected eviction, catch eviction, rising document trends, and index. Like if you have more unused index, duplicate index, automatically the system throw alarm. Okay, after 60 days, this index is not used. Can we do some housekeeping or this automatic? These things are already automated. So DBA no need to go and run some snippet and capture that information. Then you need it. This is automated at our inventory. This kind of solution need built by our in-house development team. For example, my DBOps have its own slow query capturing and the thing. You can see how that solution is created in one single dashboard. We are creating a doc examine query, use the disk, and the bytes read. Which query read more from the disk? Which query write more to disk? Which query did more doc examine? This all can be captured, but this entirely built under MyDBOps. But I like to share one more thing. MongoDB didn't have uh, a log analysis solution in-house in open source also. So what the problem with MongoDB log is every version have different log pattern. So you cannot create one unique solution to do that. That is the biggest problem we have here that is handled at our end, and we are capturing the log and we are analyzing the log and creating one beautiful dashboard at our end. um, so this help our DBA team to quickly address which query caused the problem and those things. And this is another example. You can see which query created the noise. If you see that example, right, that particular column scan query, aggregate query run 889 ms, and the query count is 122. These all help our DB team quickly handle the incident and report to the client and create appropriate index and those things. This is another example. We have P99 dashboard. What is the CPU said? This dashboard we help to recommend downscale or upscale the instance those things. MyDBOS also have a cost resource insight. So and deep query analysis, analytical system, everything in the place. What is the advantage outcome of this all solution is prevent incident before they hit production and save lakhs to core annually through right sizing and optimizing and free DBA to focus on strategic improvement instead of firefighting. So basically, since we are serving for multiple clients, so our focus on reducing our DBA time, DBA team to do a lot of analysis. We improved and we take whatever information in their desk and they deliver the solution to the client very quickly. So conclusion in all the part, MongoDB does not fail, misuse does. Most cost and performance issues come from poor schema decisions, inefficient query pattern, blind reliance on default, over engineering optimization. This all, please remember, whenever you are seeing your Mongo database. I hope it helped you guys a lot. You can connect through LinkedIn and YouTube, or you can reach out info@mydbops.com. Thank you.
Thank you so much, Manoj, for that helpful session. I'm sure everyone here learned something useful about avoiding common MongoDB mistakes and using better practices. A big thank you to all of you for joining us today. We really appreciate your time and interest. I will be sharing the recording of today's session soon. Also, don't forget to follow MyDBOps on LinkedIn, Twitter, and YouTube to stay updated on our next webinars, blogs, and community activities. If you have more questions or need expert help with MongoDB or any other open source databases, feel free to reach out to us at info@mydbops.com or visit our website www.mydbops.com. Thanks once again, everyone. Stay safe, keep learning, and we hope to see you in the next edition of my webinar. Have a great weekend. Thank you.